Okay, good. Oh, I was going to say good morning. Good afternoon to everyone. Thank you for joining us today for our LPTV Broadcasters Association monthly webinar. This one is titled Increased Power for LPTV. I am going to read from some notes because we have some amazing presenters today, and I want to make sure I do them justice, as well as set us up for our webinar today. So, first of all, many of you know me. If you don't, I recently started as the director of LPTV Broadcasters Association. I may be familiar to you as I took a sabbatical, but last year I was part of ATSC and I was their director of communications for 3.5 years. Took a little time off, and now I am here at LPTV BA, and it's just been fantastic. And we are just really excited to start these monthly webinars for our members and for those who are interested in becoming members or just interested in what we're doing. So first of all, what are we going to talk about today? What are my panelists going to tell you about? Well, did you ever wonder why LPTVs are restricted to only broadcasting in 15 kWERP? Did you ever think that the public could be better served by LPTV stations if they increased their power to the people they serve? And what are these obstacles to increasing power, and how might it be done in a way that does not interfere with any other stations, but drastically improves the coverage of an existing LPTV station? And then, most importantly, will the FCC ever let LPTV stations increase their power? Today, we're going to do a deep dive into these questions and more to find out what the future could hold for increasing power for LPTV stations. Our first panelist that I'd like to introduce is Ron Bruno. He is currently the owner or part owner of 12 Class A and low power television stations. He's also the founder. Oh, hold on, I want to go ahead. He's also the founder and president of the Video House, which is a premier full service media production company based in Pittsburgh, Pennsylvania. Mr. Bruno was on the board of directors of the Community Broadcasters Association for 20 years and served as their president for 1 year. And during that time, he was instrumental in creating Class A stations as he worked closely with his good friend and Congressman Ron Klink to create the bill. Congressman Klink was the main sponsor of Class A. We are also extremely fortunate, as Ron is a current board member here with LPTV Broadcasters Association, and he was bestowed the Mike Gravino Hall of Fame Award at this year's LPTV-BA annual meeting held concurrently with NAB back in April in Vegas. So thank you, Ron, for being a part of this. Thank you for being a part of our board. Another panelist is Dan Barton, and he is the president of Alive Telecom. He guides a team of engineers and designers in supporting the ever-changing and growing telecommunications marketplace. He gives Alive Telecom the opportunity to approach any communications project with unique solutions, general consulting, system design, or component design for specialized RF projects. Dan has presented papers at key engineering symposiums and authored papers that were published in technical journals. Previous to Alive Telecom, Dan worked at Andrew Corporation, where he was the lead antenna system engineer for the Broadcast Products Group. He was able to advance the product line that enabled Andrew Corporation to differentiate themselves from their competition. He left Andrew after assisting their startup in building Antenna Products Group. He also designed and assisted in the marketing of the antenna production line or product line. Our next panelist is Daryl DeLauder. He is the founder of DeLauder Communications, a Virginia company that has been providing engineering consulting services in the broadcast and telecommunications industries for over 30 years. He has personally helped design over 200 LPTV stations since 2021. And last but not least, we have John Shadler. He currently serves as the Vice President of Engineering at Dielectric and has been with the company for 39 years. After receiving his BS in electrical engineering from Penn State University, he began working for Dielectric Communications in New Jersey, formerly the RCA Antenna Division. He then obtained his master's degree in electrical engineering from Drexel University. His research and development achievements have been focused on unique TV, mobile media, FM, cellular, wireless, and many other special bi-directional and broadcast antenna designs. John has 44 issued and multiple pending patents. In 2005, he was awarded the distinction of joining the ranks as one of SPX's master inventors. He has been the recipient of NAB's Best Paper Award and is also the author of the VHF and UHF Television Antenna Test Range Measurements chapter in the NAB 11th edition handbook. Folks, you are in for a treat today. These gentlemen are amazing. They are experts in their field. And I'm going to turn this over to Ron so that they can start our session. Thank you.
Yeah. Thanks, Amy. How do I follow that? All those credentials. Jeez, you guys are amazing. Holy smokes. Anyway, Amy, thank you so much. For those of you who don't know, Amy's our new director of the LPTV Broadcasters Association, like she said. And out of all the associations I think I've ever been in, she's probably 10 times better than the nearest person to her as far as organization and keeping an organization together. So I encourage you, and thank you for participating today, but I also encourage you to participate in all the stuff that she has coming up, all the seminars, because she's amazing at how she puts these together and gets everybody together. And look at this amazing panel that she put together today. Oh my gosh, So I also want to thank Daryl and Dan and John for coming back today and being at NAB with us and allowing me to torture you to get our notice for proposed rulemaking exhibit published. And we'll talk all about that in a second. So anyway, the first thing I wanted to talk about is, does anyone have any idea why we are limited to 15 kilowatts ERP and UHF and 300 watts ERP and VHF? And you don't have to answer that, I'll answer it for you. So in 2004, Keith Larson, who was the head of the low power division at the time, was tasked to write a rulemaking to change analog low powers to digital. The rulemaking he created was a 200-page document, and it was filled with every possible situation that could happen during the transition, and if those situations happened, how the FCC would deal with it. At the time, I was on the Community Broadcaster Association board, and for our board, it was simply overwhelming. I mean, it didn't matter how many engineers we had, and it didn't matter how many lawyers we had. The thing was overwhelming for us to try to keep up with it. Back and forth trips to DC, phone calls all day. It took about a year to write the thing. But it was a tough document to get us from analog to digital. And so we had our hands full and we tried to negotiate every little piece of the ruling. So one of the things we had to deal with was, I'll put this up in front of my camera, was this paragraph 2005 that talked about power limits. It's one paragraph, that's all it is. And so we didn't quite understand it at the time, because you have to realize at the time we were all analog and we had all 1 kilowatt transmitters because that's all we were allowed. And we did not know, or at least I didn't know, what ERP meant. So we were used to dealing with the transmitter power output. And especially we didn't understand what ERP meant in the digital world. All we knew in the digital world at 15 kilowatts ERP for UHF was our signal could go out maybe 50 miles, which for us was welcome news because it was well beyond what we were experiencing in the analog world. So when the engineers and lawyers got to this paragraph, the engineers and lawyers from the FCC got to this paragraph in the NPRM, they spent 1 hour, 1 hour discussing and deciding this 20 years ago. Imagine that. We had to live with this craziness for this long, 1 hour, and they made this decision. So the lawyers, with the help of the NAB, because the NAB wanted to keep low power small, they wanted to limit LPTV to 1,000 watts ERP. So imagine that. We would have been crushed. But the FCC engineers, led by Keith Larson and Julie Knapp and others, explained that ERP and TPO are very different things. They were explaining that to the lawyers. 1,000 watts out of your transmitter is different than 1,000 watts ERP. So they settled on what they called a typical pattern replication of the analog signal that was there, and so the 15 kilowatt ERP was developed. Now let me remind you, they made this important decision, but there was never, ever any physical testing done by the FCC for a digital signal at 15 kilowatts ERP. Now, we were commenting on as many things as we could. We didn't understand this 15 kilowatts ERP thing. And so surprisingly, no one commented on that, and most likely because no one understood it. So what none of us knew at the time was that to achieve the 50-mile radius signal antenna, we had to shoot the signal out like a fire hose. So we would go up the antenna and we would shoot out so we could get that circle and hit the round. But what we didn't think about whenever we were shooting out like this was all these people below it. What's happening to them? All we were thinking about was, hey, because in our brain, we thought, well, gee, if it goes out that far, everybody must be able to see it. Boy, were we wrong. Okay. So anyway, therefore, we had to live with this problem, and we said, man, this is horrible. And people have tried many, many ways to get around it with, circular polarization and all that kind of stuff. So now some of you know that as a result of the repack, the FCC kept 4 Class A stations out of the auction. I own 2 of those. So after a long lawsuit, a couple years, we ended up with a settlement. And part of the settlement was that 2 of our stations could increase, the 2 that they kept out of our stations, we could increase the power to 30 kilowatts ERP. So my great friend and partner, Larry Rogo, engineered a beautiful transmission system where we used 2 7.5 kilowatt transmitters, and we combine them in the ground, and we send them up a 3-inch air line and out to a circular polarized 4-bay antenna at 450 feet above ground. And when we turned that thing on, man, it was stunning. You could get that signal no matter where you were, no matter what you were doing. It was unbelievable. And it was only 15 kilowatts more than what we had before, double the power, as opposed to the megawatt stations that are our full power stations here, 1 million watts. So as people started to ditch cable, we started to see a whole new group of viewers watching our stations, and we started to get calls from all kinds of viewers with the really dumbest things like, hey, your programming guide on I Love Lucy's, that's the wrong episode. The episode you're airing is this one, and they were all worried about the programming guide. And at that point, I realized, wow, this is really something. This is like how it used to be when I worked at a full power station. People are actually really able to see these things. So it started my fascination to talk to viewers and ask things like, what antennas are you using and where is your antenna located? Now, the situation's pretty interesting in what I'm talking about with these 2 Class A's. They're both at 450, and the channel 26 is virtual channel 61, and channel 30 is virtual channel 69. At the same height, 4 feet away, is a regular low power 15 kilowatt ERP, and it's 15 kilowatt ERP, and we're all together. We're right there. So so that channel 24 is mapped to it's virtual channel 65. So I would talk to these viewers and I say, can you see any channels in the 60s? They go, oh yeah, we get all the 60s. Well, wait a minute, what do you mean all the 60s? Well, we got the 12 channels on 61, because we put 12 on 61 and 12 networks on 69. And so, and I said, well, what about channel 65? Oh, I never got that before. I go, why don't you try? So we try, and the farther you would get out from the city, or the more inside a building people were and not having an antenna on the roof, you couldn't see channel 65, but you could still see us and all the full powers. Okay, so anyway, my little thing from trying to listen to viewers was that about 70% of them could not see this channel 65, but they could see us on 60, just with 30 kilowatts ERP circular polarized. So we did a little investigation for our notice for proposed rulemaking filing, our exhibit, which, by the way, before I forget, every one of you on this call are going to get that exhibit on your email so that you can see what we're talking about, but I'll explain it to you right now. So 80% of the antennas sold in America are indoor antennas. Most of them are junk. You know, they're Motu leaves, some kind of little, bar or something you're supposed to stick on the back of your TV. They're installed upside down. They're laying on the floor. They're doing this, they're doing that. And basically, most people that have them work and they just have their RF connector connected in the back of the TV and they're receiving the full power stations because it's bouncing around so much, they got to get something. So that's what they get. But anyway, a lot of these people were getting us too. So now, in all fairness, all the people that had an outdoor antenna, even 50, 60 miles away, for the most part, could see everybody, even some of the other low powers, okay? So when this notice for proposed rulemaking for online public filing, the online public filing notice came out, I thought maybe this is a good time to suggest a power increase to the FCC. So I called my good friend Daryl DeLauder and I said, hey, Daryl, how about, do you want to work for free for a little bit and help us out here a little bit? And he of course said yes, and was very gracious. And he helped us figure out a way that we could do a power increase. And so instead of shooting your signal out like this, what the idea is you shoot your signal down like a cone, but you still cover the same area that you cover. Well, if you tried to do that under today's rules, you would have to put down more than 15 kilowatts ERP. And it turns out that why couldn't we do this? The full power stations have been doing it forever. So Daryl and I talked about some of the stuff that I had that maybe we could try it out on. So Daryl designed a beautiful engineered station in Jacksonville at 750 feet above ground. And he asked me, well, how powerful do you want to make it? And I said, I don't know, let's make something up. How about 250,000 watts ERP, which is 17 times what we could do. And he engineered it beautifully and it worked and it stayed within our 15 kilowatts to the horizon. And the only problem for me personally was that we needed a 29 kilowatt transmitter and a 600-pound antenna with a cost of over $1 million to do this. And that was a little bit out of my league. So we never ended up building that. But I had a 5 kilowatt transmitter because at the time we were using a 2 kilowatt. I said, why can't I just put this 5 kilowatt up here and, put an antenna? And, I talked to Dan and I talked to other people at Dielectric too. I said, why can't we have this antenna with this 5 kilowatt? And why can't it accomplish the same thing? Just put bigger gain on the antenna or something. I'm not an engineer, so I don't know anything, but I was asking why can't we do it? And Daryl said to me, you just might as well stay with your 2 kilowatt transmitter because you wouldn't gain anything. So right before the NAB, I was I couldn't explain this to the other engineers that I was talking to. And I said, well, how about if we put together a panel and let's talk a little bit about this and how it works. And they were so gracious to help me out, and John and Dan and Daryl. And so at this point, I'm going to pass this discussion over to Daryl so he can explain how all this works and possibly what we could do, keeping in mind that in the current situation that we would have to stay with 15 kilowatts to the horizon and not interfere and not go over that. So Daryl, there you go.
Thanks, Ron. I really appreciate it. You have a better memory than I do of what we did in Jacksonville. but we tried our best. For the panel discussion at the NAB, I pretty much just acted as a moderator. And so that's basically what I'm doing here. So my comments are going to be really brief. As a matter of fact, Amy in her introductory comments stated, the difference in power or the limitations, at least for LPTV, and Ron's alluded to that too. If you think about it, the difference is 67 times. That is for UHF, the UHF TV station, the maximum allowed ERP is 1 million watts. And as mentioned, we only get 15,000 watts for LPTV. So that's a difference of 67 times. So we're just trying to lessen that imbalance with whatever we propose. And, we're not looking to propose a set number to the increase. So as Ron pointed out, it's more of a concept. We're trying to increase the radiated power downward and maintaining the same ERP on the horizon. And why do we have to maintain the same ERP on the horizon? Basically, the FCC is not, at least initially, let us get away with a power increase if we're not showing the current protection to especially co-channel stations are on the horizon. So at some point, maybe in the future, after we are successful with getting this increase downward, we can go back to the FCC and say, hey, look, there's some practicality to the fact that we should just be able to go up further than 15 kilowatts on the horizon if we protect people based on your computer programming, your TV study programming. But we're not going to go there initially. What we're going to do is we're going to make a strong push for increasing the radiation downward. And now we got two experts, got two great antenna companies with us here today. So I'm going to let them get to their presentations because that's the important part. They're going to tell us how we can do this, what kind of limitations we might have. I think when we get to the questions and answers, I do want to fill in a little bit on what the concerns the FCC has. But first, let me just pass it on. I don't know who's going first, but we have Dan Barton, we got John Shadler, and one of you guys take it away.
All right, I guess I'll take it away. Let me share my screen. You guys hear me?
Yeah,
Yes, we got you. Thank you, John.
Okay.
I'll let you know. Yep. We've got your screen as well.
All right, good. Welcome, everybody. So I'd like to walk through a kind of a simplified example, but I think it'll demonstrate what Ron and Daryl are describing here. So let's just, like I said, do a very simple example. Let's assume we have a 10 kilowatt ERP. We have an omnidirectional azimuth pattern, an antenna elevation gain of 10. For simplicity, let's assume we got no losses, and we have the 1 kilowatt TPO on our transmitter. So if you look at the peak of the main beam, assuming that, let's put it at 1 degree beam tilt, that 10 kilowatt ERP is at that point. So that places, again, let's assume that this places the 10 kilowatt ERP at the radio horizon, wherever that is. That could be, it's highly dependent on the height above average terrain. It could be anywhere from 2 miles at 200 feet. It could be 25 miles at 2,000 feet. But for now, let's just assume no matter what that contour size is, that it places the signal strength within the licensed contour. So now let's shift the elevation pattern. Let's shift the beam tilt out to 6 degrees. In other words, point it much farther down, using that, getting that cone effect that Ron was talking about. That places the 10 kilowatt ERP now at that 6 degree point. And let's we still have the TPO of 1 kilowatt. Now, if we go back and look at where the radio horizon was at 1 degree, the ERP is only 625 kilowatts with 1 kilowatt TPO. So now, since that is the contour, the radio horizon at that point, let's increase power at the 1 degree point back to 10 kilowatts. To do that, we have a new TPO now of 16 kilowatts. So what that does is, see if you guys can see my mouse here, but now at the 6 degree point, you now have 160 kilowatt ERP, and you haven't violated the original contour. You're basically carpet bombing, if you will, or saturating, the contour area. So let's kind of just look at this a little bit differently and look at the two scenarios, plotted them in dB. The black here is the original 1 degree beam tilt, 1 kilowatt TPO. The red is when we shifted the elevation pattern to 6 degree beam tilt with a 16 kilowatt TPO. The yellow is basically the power increase that you see within the contour. Here's your radio horizon, and you can see that the signal level is still exactly the same between the two scenarios right at this point. And beyond the radio horizon, let's say outside the contour, again, I'm assuming the contour is their radio horizon just for simplicity, but beyond that, you can see that the high power situation actually has less signal strength than situation. So, so basically, we have really saturated up to 50 to 20 dB more signal strength in that coverage area. Just to put that in perspective, that's 32 to 100 times more power. And we've done this without putting any more power outside the contour. Now, again, you have to understand that the size of this saturation area in terms of coverage is heavily dependent on the height above average terrain. If you're pretty high up, you can have a very large saturation area. So that's the example that I wanted to run you through on how this can actually work. I will stop sharing, and I don't know if we want to wait for questions or what the plan is now, or just hand it over to Dan.
Why don't we take just a quick second? I forgot to mention at the top of the session, there is chat. If you have a question or a comment for our panelists, you're welcome to use chat. Otherwise, we'll open it up for Q&A at the end. But let's just take a minute. Does anyone have any questions or comments? You're welcome to raise your hand or just open your mic and ask our panel. Okay, I'll let you guys carry on then.
All right, hopefully you can hear me okay.
All good, we gotcha.
All right. All right, well, again, thank you very much for the opportunity to be on the webinar here with the Low Power TV community. And thank you for the nice introduction, and Ron and Daryl and John. It's great to be with you on this panel. My name is Dan Barton. I am with Alive Telecom. We're a antenna manufacturer in
Uh-oh, Dan, I think we locked up on you. Is it me, Ron, or is it Dan?
beam tilt.
He locked up.
Whoops.
Hey, Dan, you locked up. Can you please repeat that again? We lost you.
Sure. Sorry
We
about
lost
that.
you for a second there. Thank you, Dan.
Yeah. All right, let's try that again. So I was just thanking everyone for their time and all. And I wanted to continue on to what the previous speakers were mentioning about increasing the beam tilt below the horizon to achieve a greater saturation while staying in the envelope of the 15 kilowatt ERP limit at the horizon, which is the rule that we have. And as Ron had kind of mentioned, there's probably no way of really getting around that 15 kilowatt. But if we do get the access later on to use some engineering tactics, if you will, to increase our TPO to get a better penetration and therefore better signal strength and signal density to get greater viewership. And that way the low power TV community is on the same footing as some of the high power stations. So very similar example here. Staying in the envelope, 8-bay, this is directional. This is using HFSS. We also use another program called CST for high frequency modeling. And with that, it's great. You kind of build the antenna before you build it. You have a 3.5 degree beam tilt here, which puts you at minus 3 dB at the horizon. And at your peak, you get 30 kilowatts ERP. And then if you want to do a 6 degree beam tilt, that puts you at minus 9 dB at the horizon and 120 kilowatt ERP at the peak. So a couple of things that got mentioned today that, you know, it's kind of interesting. This adds a few more levers to the design. You're kind of balancing out your height above average terrain. You're also balancing what transmitter you're capable of having, using, of forwarding, both capital expense and operational expense. So if you don't want to have a 10 kilowatt transmitter, but you have maybe a 6 or 5 or something like that, like Ron said, we could actually design the antenna to the ideal beam tilt. You don't have to necessarily be pigeonholed into just 2 degrees, 3 degrees, 6 degrees, or so forth. We could actually look at that in the process of just same thing as figuring out, you know, what your interface to your tower is, just part of the actual system. So this is the standard pattern design that we do. So this is, you know, elliptically polarized. You have your horizontal, which is the red. I'm looking at the left here. Let me get my, oops, all right, what happened there? All right, that's our horizontal. Hopefully you can see my mouse moving around. This is the vertical component. So you got your delta, that gives you your elliptical. Yeah, no matter what we do, we always got to make sure that we're, you know, inside the contour of the horizontal. That's what you license for. And this is a standard elevation relative field. So you have this marker here, which is at just 0.69 or something, just underneath 3 dB mark. And you can see that's above the horizon a little bit. And then you're right here, it peaked out at 1 degree of tilt. And as you can see with 3.5 degrees, you do what we do is with the NFED design, you have non-uniform spacing. So you can kind of adjust the slot locations to create a phase delta from start to stop of the array. And that allows us to get the beam tilt. And then you use some other tricks with amplitude taper and so forth, and you get this nice null fill in there. So this is a 3.5 degree, again in dB. And then this is a 6 degree. So you kind of see here where we're falling. We're down minus like 9 dB at the versus minus 3.5 or so at this one here. So between all this, you can see you get all this nice fill in. And then the other thing that, you know, I always want to make sure about too is that we're not wasting energy above the horizon. So sometimes there's a tendency when you have extra beam tilt, you get the secondary lobe that comes up. We always want to make sure that we kill that so we're not, you know, broadcasting to the birds. They don't really watch the commercials that everybody else does. So these are just some of the things that go through to get from this type of scenario to this type of scenario. You get nice null fill in there. So that's my presentation there.
Well, thank you. Quick question for John and Dan. Do you have any issues with sharing your presentations with our attendees today?
No problem.
No
Okay.
problem.
Okay, and I think you've already sent them to me, but if not, please do. Dowen, yes, we will include the presentations, the link to this recording, and then the filing that Ron mentioned that went to the FCC last year. All of those materials will be sent out to the attendees after the webinar. with the presentations, does anybody have any questions for our panelists at this time? And then I'm going to throw it back to Ron.
I have a question, believe it or not. So can one of you, Dan or John, explain to me electronic beam tilt as opposed to a mechanical beam tilt? I'm sorry, I just don't know what that is.
Yeah, I can take that one. So electrical beam tilt basically means that your antenna is completely vertical and that you're bending the beam that we're talking about, that 3.5 or 6 degrees electrically. You're not physically bending the antenna to force the energy down. Mechanical beam tilt is where you physically bend the antenna, again, to create that beam tilt. So that's the difference.
So when you say electronically do it, there's no electronics in any antenna I ever got.
No, it's basically the phasing that Dan was just talking about. If you change the phase progression of the slots or radiators, whatever they are, along the aperture, you add those vectors up, it tends to bend the vectors down towards the ground.
I would like to add one thing to that. If you use both electrical and mechanical beam tilt, you can achieve a very deep null if you need to protect a particular station and then come out of it very quickly in other directions.
Correct.
True.
Yeah.
Yeah, that's a good point, Craig. I was just also going to mention about the mechanical. Now, when you do whatever you do to one side, now the other side, you're going back. And
Yep.
like you mentioned, Craig, sometimes that's beneficial if you're trying to protect something. That elevation pattern that's usually normally above the horizon is even more above, and you could kind of get that little null in there. It's a little tricky at times, especially for side mounted, because you got some scattering going on too. So modeling versus real life could be close.
Dan, what was the power output on the transmitter on your diagram that you used?
Oh, I was just, I was basically just doing gain. I was doing like zero loss on the line. So it was kind of nothing really. I mean, it was TBD, to be honest with you, because it would be based on, 1.5 kilowatts with no loss in the line, that kind of thing for 15 kilowatts. So then it would be three kilowatts for 3.5, and then it would be like 30 kilowatts at 6 degrees, or just about 27.
Okay, gotcha.
Again, that's with no line loss or anything like that, because it's theoretical. Yeah.
Okay, I have a question concerning number of bays. Let's say, as an example, you have a tower that's looking over a city, and you're at 800 feet, and you're using 8 bays. To keep that 15 kilowatt on the horizon, what do you think, just generally, is going to be allowable as a maximum ERP below into your service area? And then I want to do it again for 16 bays. So does one of you want to take that?
Yeah. So obviously the difference between 8 bay and a 16 bay is the beam width of the main beam. But a 16 bays, in order to put that null that's usually above the horizon at the radio horizon, you have to shift it more because the beam width is wider. So if you go to 16 bays, you may not have to shift it quite as much because the beam is narrower and you don't have to shift it as much. But the trade-off is if you go to 16 bays, now you have that narrower main beams. Saturation area that I'm talking about is a smaller, say, donut shape within your contour. The wider the main beam, the broader that saturation area is. So it's a trade-off. You have to analyze and look at the actual coverage calculation of height versus number of bays and gain.
The only other thing too, Daryl, is the azimuth pattern. So if you have an omni, you basically full circle around, you'll see that delta between 8 and 16 bays with a directional, say a 2.5 dB direction as pattern. You keep that the portion the same no matter what you're doing with the beam tilt. So you know the TPO requirement will be less just because of that directionality of it. The gain you're getting out of the azimuth that doesn't change no matter what the beam tilt is.
Can somebody speak about null fill?
Sure, more is better. That's what we seem to have been finding out. Although it is a trade-off too, because you lose some of your gain. You got to put the energy somewhere. So that's kind of our take on it, is that we encourage it. We think it's a good idea. We think that it helps the antenna perform better, or at least the signal density is better. But you got to be aware that you might need an extra, you know, in a low power TV world, maybe an
Yeah, the other thing to consider is, you know, where
depending
the
on
antennas,
where you're at.
you know, where the antenna is located versus your population. You know, if you're have nothing but cow pastures for the first 5 miles or so from your, you know, from your site, or 10 miles, you probably don't need any null fill, because that's where, you know, that null is going to lie. So, you know, again, it depends on if you have population that's pretty close to the tower itself, you certainly want good null fill.
One of the things that the FCC brought up to me when I was discussing this earlier with Mark Colombo in particular, he said, you know, I think one of his concerns seems to be maybe a proof of performance. That is, to make certain that the antenna is operating as proposed. Can either one of you guys speak to that, or both?
Yeah, I mean, certainly we do testing to validate the performance of our antenna, not only for VSWR, but we do something called near field probing, which validates that the elevation pattern is what it's designed to do. And measured data actually goes to the customer with every antenna that we make.
Yeah. Then there's an after the fact part too. There's third party services that do scanning, if you will, or you know, just real world measurements on a tower with a drone and whatnot. So, which has become a little bit more approachable between the cost of the gear and the amount of people that are doing it.
Kind of a newer way to go with things these days.
But the thing is, like for FM stations, if you're a full power directional FM station, you have to take into account the exact tower design, and the tower manufacturer or the antenna, well, the antenna manufacturer will take drawings of your tower and model it as best they can to make sure that you meet the directional pattern as part of your proof of your pattern is what it's supposed to be. That is much more expensive. And if that's what Mark Colombo is looking for, that's a different story than just, is it mounted correctly and all that? Because you're really taking the face, the size of the face of the tower, how the antenna is positioned, whether it's leg mounted, face mounted, is it offset on a leg or whatever. So I hope that's not what he's talking about, because that's very expensive as it is for an FM station.
Yeah, I can't put words in his mouth, and it was more of a general conversation. But if I had to weigh a guess on how he thinks and what he's thinking about, he is thinking along those lines of going to that more detailed type of proof of performance, where you do need, you know, tower specifics and the mounting specifics and so forth. So.
Daryl, did Mark say anything about like issuing a couple STAs for us to try this out or anything like that? You know?
You can always give it a shot, right?
Yeah.
No, I didn't talk to him about that, but I did talk to him this morning. But Ron, you were going to fill us in on some. Let me pass back to you, Ron. You had some more comments maybe on where the FCC is with things.
Yeah, I was gonna end with that if everybody's done with the technical questions, so I can wait
We
till.
have one question though in chat from Jonathan, and it says, is there any data showing the amount of people that you would pick up by increasing the down tilt by 3% in an urban area for an LPTV station if you have the same coverage at the horizon? So somebody is welcome to take that question.
Yeah. But 3% probably means 3 degrees, I think, right? That's probably increasing it down till by 3 degrees, I'm guessing. Yes.
Yes,
Yes, okay.
sorry, by
Um,
3 degrees.
yeah, okay. Um, it's tough to put a number on it because, just there's so many different environments and such forth. You could talk about signal density and you could talk about increased signal level, which would just be kind of the dB value that you're increasing it at that radial close in. But I wouldn't gather to give a guess on the people count.
Now, certainly you're increasing the probability of reaching more people by increasing the signal strength. And again, as Dan said, a lot of it has to do with environments. Are these, deep indoors, with Ron was talking about, or do they have an outdoor antenna at 30 feet? There's a huge difference. So, it depends on the population style that you're trying to hit.
Okay, it doesn't look like we have any more questions in chat. Does anyone else have a question before we turn it back over to Ron to kind of take us home?
I was just going to say, I had my mic muted. I was just going to say that as far as closer in, you can use Longley Rice and you can be very precise as to how much signal you want to fill in closer in. And use different amounts of beam tilt or null fill to determine if you're reaching the signal level, if you have an idea what signal level you want to attain. And again, as you get closer, more people may be using indoor antennas, and you really have to take a lot of factors into account. But you certainly can do a lot of experimentation with the programs to determine how much signal you can increase by using varying amounts of beam tilt and or null fill. Thank you.
Thank you, Craig. Anyone else? Mr. Bruno, I think you're up.
Okay, so probably the biggest question is when will this happen, or will it ever happen, and what's the obstacles? And I don't have the exact information, but I can tell you what's going on. So it seems like everybody that we talk to in the engineering world at the FCC agrees that this is a great idea. And the reason why it's a great idea is because it serves the public. And that's what we're all here to do, is to serve the public. So, we're taking up a circle of this much coverage area, and a lot of people in that circle can't see us. So it's wasted, and this will unwaste that. So the next question is will there be a limit on how much we put down? And we, as an organization, are going to fight any limits aggressively. The limit needs to be your pocketbook. The limit needs to be the height of your tower and where you're at. And the limit needs to be the best engineering that you can come up with for your situation to cover as many people as possible. Okay, so we filed the exhibit that all of you are going to get on your email in the filing that happened last year, the NPRM, which was called the Online Public File NPRM, and we had it there. We refiled it again with a delete, just so that we would just keep pushing it there. It was the same thing. It was a power increase analysis, and it was an exhibit, and we filed it there. And so we we also know that we could be fourth in line after those two, and the other one could possibly be them opening up, the FCC opening up a new window for new applications. And it sounds really bad that we have to wait that long, but think about this. Right now, what they're saying to us is that you have to limit to 15 kilowatts ERP to the horizon. If the FCC decides to have another window and people apply for new licenses, and theoretically everybody in the world that's going to apply for a license applies for one, and your signal could be extended a little bit without interference because nobody applied for it, so nobody wants it. So why wouldn't you let us, FCC, serve the public after you did everything in the world you could do to give people opportunities to get a new channel? So waiting till after that, if there's going to be one, waiting till after that's over might actually be better than us getting this very, very, soon. But I got to tell you that from Keith Larson, who designed it, and he said, "I know there's something wrong. I just don't know what it is." Now he's in our favor. Julie Knapp, a lot of current engineers at the FCC say this is just the greatest idea ever, and so we have a lot of positive momentum. And I think if we get this ruling, prior to an open window for new applications, I think it's going to be limited to 15 kilowatts ERP. I think if it's after that, I think we have a really amazing argument to say, hey, why can't we just go up to wherever our interference contours are? Or whatever our interference is, so that we don't interfere for other stations. So I think that the FCC is a little bit overwhelmed and really doesn't want to talk to me about this, because every time we're there, we're always saying, hey, what about this? What about that? Our lawyer for our organization, Frank, same thing. Everybody talks about it all the time, and they keep saying, hey, give us some time. We got this other stuff on our plate. So the good news is the other stuff that's on their plate is happening really, really fast. And so I'm going to say that hopefully by sometime in NAB of next year, that we're going to see some sort of movement on this, and you're going to see a lot of push from the organization to get it in front of them and to get them to do something. And I think we'll also see a lot of rulings happening, like this online public file and the 5G broadcasting. I think we'll see a lot of those rulings go through before NAB. So keep your eyes open. I'll be posting as much as I can. And so I'm sure Amy will too, about what's going to happen on this. But I think that if we're taking up this much space in our coverage area, at least at the very minimum, every single person that has an antenna, whether it's upside down in their living room, in the middle of their house, or wherever it is, and if they can see a full power station, they deserve to see us. So there you go.
Good closing message, Ron. Thank you. It also sounds like it would make for a great session at next NAB. I want to thank everyone for joining us. I especially want to thank Ron, John, Dan, and Daryl for agreeing to do the panel today. I appreciate it. As I said, I will send out the recording, the filing that Ron has talked about, and the presentations that were shared today to those that were on the call and not on the call, but registered. My virtual door is always open. And so please reach out if you have any questions or comments. We're working on next month's webinar. I just don't have the topic or the date settled yet. So look on our website or our newsletter for further information. And again, thank you. And I hope you all have a great rest of your day. Bye.